Homework 2.7, inverse functions, video 5. Homework due Friday, May 22nd, 2020 at 11:59 p.m. The following video correlates to questions 8, 9, 10, and 11 in homework 2.7. So we've defined what an inverse function is, well, what inverse functions are relative to each other. And we talked about a couple of ways to determine whether or not a function has an inverse, the easiest of which is to look at its graph and see if it passes the horizontal line test. There's an algebraic way to determine if a function is one-to-one, but we're not going to worry about that in this class. But now it raises the question, suppose a function is invertible. Suppose its graph does pass the horizontal line test. What is the inverse function? Now sometimes they're obvious, like the inverse of multiplying by 2 would be divided by 2. But what about a function like f of x equals 17x plus 39? I'm telling you it's one-to-one, but it would be easy to check. That's a line. It's a steep one because its slope is 17, but it's a line and it's not vertical, and it's not horizontal, so it passes the horizontal line test. So it has an inverse, but how do we find it? Well, luckily there's a really straightforward procedure for finding the inverse of an invertible function. And I've got it set up over here. It's a 4-step procedure. So we'll find the inverse of this function while setting up this list. Step number 1, change f of x to y. So literally change it from f of x equals to y equals. That wasn't hard. Step 2 is just as easy. Switch x and y. So we're going to take this equation and everything that's an x, we write y, and everything that's a y, we write x. So x equals 17y plus 39. Now what we just did is we buried the output inside the function. We're going to dig it out by solving for y, and as we do that, we will be building the inverse function on the other side. Step 3, solve for y. This is the step that there's actually work to do. Sometimes it's easy, sometimes it's challenging, but our third step is to start solving for y, the way you would normally solve for a variable. Now, the hang up here, and it's a very minor hang up, is as we start doing the moves to get the y by itself and match those moves on the other side, we can't actually calculate anything over here because we don't know what x equals. For example, our first move for solving for y would be to subtract 39 from both sides, to cancel the plus 39, leaving the 17y by itself. But what's x minus 39? I don't know. All we can write is x minus 39, but that's okay. Our objective is to get the y by itself, and this gets us a little bit closer. The last move, of course, is to divide by 17. So we get y equals x minus 39 over 17. That is your inverse function. And the last move is more cosmetic than anything. Change y to f inverse of x. So our answer is the inverse of f inverse of x, is x minus 39 over 17. And you don't have to verify it by doing a composition in both directions. And you don't have to check the domains and ranges. As long as it's one-to-one and it's invertible, we're going to assume that they behave. And that's it. I feel like we should take a look at another one, because that didn't take very long. I know. Why make the video longer? Because I know it's in your homework, and I know you would appreciate an example that's a little bit more involved than this one, and I've got one in mind. Let's do the same thing, but what can we put in this function that could possibly make it more challenging? Well, the same thing you can put in any math problem to make it more challenging. Let's try f of x equals 3 over x plus 4. Now, we haven't graphed anything like that yet. When we get towards the end of chapter 3, we will. But I will tell you right now that its graph passes the horizontal line test, and this is 1 to 1. And we're going to find f inverse of x. The fact that it is a rational function, a function that's a fraction, doesn't change the procedure. Step 1 in our answer, call it y equals. I should have asked you to pause the video and try to solve this on your own. You're welcome to do that anytime I pose a problem, even if I don't stop and explicitly say, pause and try the problem on your own. Step 2, switch the x and y. Okay, x equals 3 over y plus 4. Now for the fun part, solve for y. Any suggestions? Of course I can't hear you, but that's what I would ask if I were face-to-face in the classroom. Well, think about where the y is and where we don't want it, or where we want it. The y is currently in a denominator, and we want it by itself. You will never solve for something as long as it's stuck in the bottom of a fraction. So I need to free this from the bottom of the fraction. Frankly, I need to get rid of the fraction. Oh, we have a move for that. The move for getting rid of a fraction is to multiply both sides of the equation by the denominator. So let's multiply both sides of this by y plus 4. That will cancel the denominator on the right and leave us just 3. And on the left, it sets up what looks like a distributive property problem, and I think I will distribute. Why? Because we're solving for y, and it's currently trapped in the parentheses, and I don't want it there. So I'm going to distribute the x. That'll give us xy plus 4x. Let's move this up here. Okay, this looks congested, but manageable. Keep in mind that we're trying to get the y by itself, and we can do it in 2 moves. Number 1, get this guy out of here. Number 2, divide by x. So let's get this guy out of here by subtracting 4x from both sides. And we get xy equals 3 minus 4x. And now we can divide both sides by x, and that'll get the y by itself. We get y equals 3 minus 4x over 4x, which is a perfectly acceptable stopping point. Now, if you're feeling the temptation to cancel these x's, you need to resist. The rule for reducing in a fraction hasn't changed. You can only reduce parts of multiplication problems, not parts of subtraction problems. And if you're going to go, yeah, but I know a workaround, great, you're learning. If you want to reduce this, if you insist on it, then you must split this into 2 fractions first. Because then, after removing the subtraction from the fraction, these x's are eligible. So you could say 3 over x minus 4. Now, either of these are acceptable. You would probably want to stop here because it's the first one you would get into. Technically, we found the inverse function, but the 4th step is to just, say we found it. So f inverse of x is 3 minus 4x over x. That's not an x. Or 3 over x minus 4. Either one would be acceptable. All right, so to find the inverse of a function that you know is invertible is pretty straightforward. It's 4 steps, 3 of which are really easy. It's the solve step that can be tricky.